1, 2, 1, 2. Welcome, my name is Michael Wickerson, and I am now on to a script series that is probably one of the most intimidating and most enticing scripts that I'll be showing in this series, partly because it's focused on the sets tree section of Grasshopper, which is, the section that has so much possibilities through masks and offsets and path mapper and a wide variety of very powerful nodes. And as you can see, just looking at activating the application of those scripts in 1, 2, 3, those nodes in 1, 2, 3, 4, 5, 6, 7, 8, about 10 scripts, I'm going to pan out of the Rhino window, and you're not going to see geometry so much as you're going to see information. And as we move out, you can start to see the complexities of really getting in here and thinking, what is happening? What have I done with a series like this, and why does it look so chaotic and difficult to understand? So I'm going to go back in here and grab, obviously, what it looks like in a 3D mode and say, if you're interested in understanding the logic behind visualizing your data and gaining control, then you, as a intermediate advanced Grasshopper user, probably prior to going into designing your own custom user objects and scripting and compiling things from Visual Script Studio in Python or VBScript or let's say a C# script, this is where you end up. So it might be easiest if I take each of these scripts and produce a short little video. So as I zoom out, I'm going to take all of this section here, and I'm going to disable that. And I'm probably going to grab all this section here and disable this. And let's see how far and detailed we can get just with this first section. And let's jump on in and see the fun. Learning to manipulate data trees is essential. Be sure to use your visualization nodes. And I think what we have here is application as we go farther along. But we are looking a lot into panels and a lot into the param viewer to find out what's happening. And I think this comes from Daniel Christoph, I can't remember, but throw a series in, use your cross references, graph your A list, and produce a constructed points. And we'll go here and show you produce yourself a wonderful grid of a list of lists, which will end up reading as tree data. And we are running this extremely small at a step of 2 from 0 and just in 3. So if we start taking this data just up, you can see how complex this thing will get very quickly. But you want to start with a simple model of that and then start breaking down what's happening. Up here, I have a plane that I internalized and decided to put it into a rectangular grid, which would then give me a list of lists as well. And coming out of the cells, it's a wonderful way to gain some tree information. And also the points according to that grid, and you can do your X and Y extends. You just need a plane to play off of, and that's the default XY plane. So I actually didn't import it. I think it's just, maybe I did. Let me just right click. Yeah, I did internalize a grid. But let's skip that first little section and jump into this kind of 3D grid that's been built, thinking of Daniel Christoph's model. Flattening the tree is what we basically want to get into. We want to grab our list numbers and see what's happening here. And you can see we have 3 sets of 9 numbers, and that goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, and we go to the next row. And if you start thinking of these as kind of library books, and I'll shrink this down so you can see what's going on, kind of card catalog, library filing system. Very nice system to see the tree data that you've ended up producing. If I was to flatten that, and we've done this on a couple of visits to the path mapper, you'll see that all of a sudden I'm left with a number system that has every number starting at 0 and running all the way through to 26. So we have 9 times 3, which is 27 bits of information. And that's exactly what reads in the param viewer and definitely reads in the panel tool. If I was to use the graph node, and I'm literally going down here applying these nodes, and these all can be tucked into the actual path mapper, which we'll end up gravitating towards. Most people kind of stop short when they get into data trees, start looking at their param viewers and try to make sense of these tree branch representations within the panel tool. But go deeper, keep trying, and you'll see here a grafting doesn't let any number system really come about because every single item is on every single one of its own branches, and there's an image of that. So there is no tree data that's putting them all on one or breaking them up into different branches. So this is a great exercise to have this file and start to visualize and conceive of. And one thing I haven't done here is with those points, I think it's very good for people like me, not saying you're like me, to grab yourself a polyline tool and visualize what's happening through those sections. So my points coming out, I have grafted information, but I want to grab all those points and roll down here and say, okay, that's how the lines are being read at this stage. When I take it through a little bit of manipulation here, and this is an example of not being able, I believe, to grab the vertices through. Actually, I still did. That's nice. Still grab it through a number slider. It's something I've warned against before, trying to grab data and run it through. And there's a flattening, so it's one line that runs all the way through all 27. And then this one will produce no lines because it doesn't have 2 points to pull from. Every point is its own line, which, you know, a point as a line doesn't make any sense. You're going to need a couple of points to begin that. So I do like this thing coming from my background, but for those that are much more, you know, mathematically inclined or intuitive or engineered, that you might be able to visualize what's happening within some of these nodes and conceive of that. I'm getting better at it. So let's just graph that information, take it to a simplified tree, which I think is nice. Pulling the data and what's actually happening, you'll find that all these added zeros have been made here, but they don't really do anything. There's no reason to have 0, 0 and then a number system that goes from 0, 1 to 0 all the way up to 8 in one situation, and then the second column goes from 0, 1, 2 numbers, and the rest all remain as zeros. A simplification simply, let's just see, cuts off those useless branches and brings you down to the core values that are essential. And simplifying is something used quite often within nodes, and maybe you don't visualize what actually is happening there. A nice way to look at it is get in here to the data tree, not just seeing the numbers disappear from the param viewer, the zeros disappear from the param viewer. You'll see a cleaning up of how this visualization is happening in the tree data. And then I have a path mapper, which does pretty much the same thing. I think this one is a trim tree component that takes a certain amount of branches and makes them less and packs more items onto less branches. And that's how we go from 3 branches with 3 items each, or 9 branches with 3 items each, to 3 branches with 9 items each. And I might be talking a little bit about flip matrix when I'm doing that. And that's a very simple system. If you have a single path down this side, a single branch structure, you can flip the items on that with the number of branches. And that's an incredibly useful common tool of what people use. And I start with those because just the visualization, like I said, of what's going on there is enough to start wrapping your head around. And as you see, I'm starting to produce a number system that's at different sizes, so you can see the complexities of actually what's there. Once again, I would say ungroup this. You can get in, wrap your head around what's happening in each one of those nodes. I think I may make it so we can see everything and see wonderful color, because that's a tool Grasshopper does to try and make things understandable for yourself. And as I move into these different visualizations, let's move this one down a little smaller so we can kind of appreciate that in between, and maybe make it up a little bigger. So we've rounded off the numbers to be different sets, so you can see the complexity of how much the data is being manipulated, which then drives keeping things in order, keeping your script running well. You don't have to clean the tree. You don't have to clean it up. You don't have null items. You haven't lost sense of it. And you're realizing the logic and computational organization associated with controlling your geometry and having really wonderful, well-tuned programs in scripts and nodal scripts in Grasshopper. The better you get at this, the more you'll be able to flow into a non-spaghetti-like formula into a simple top-down algorithm written in many other programming languages. So that's a lot, and I kind of mentioned clean tree, so we're going to jump down there right away and get into that. But once again, when you get through here and you say, I think I have an understanding of that, group that again and put it to a color that gives you a good feeling that you actually feel like you're starting to wrap your head around it. And let's at the 10-minute mark, let's try and run this into another section of bringing this to life. I'm going to take this to enable, And we'll give that a second to load up because we just introduced something totally new. And I'm going to use my left to right selection here of everything inclusive and take that to disable. So now I have a totally different model of trying to make sense of it geometrically. And I think I have some piped lines here, which is going to slow it down. Let's go ahead and see what we actually end up doing. Once again, when I recognize the range in a domain relationship, I know I'm probably working on a 2D grid, possibly. That the domain is in the X direction and Y values are going through the range. I have quite a bit of items here, 120 for circle radii. And because it's a big script and it might be moving a little slow, I might slide in this little tip for you to go into preferences. I think it's here, or spacebar. It's been a while since I used it. I think I can just jump into here, preferences, get down to my widgets and ensure that I have my profiler on, which tells me show profiler widget. I'm going to use that, and you can adjust it in Rhino 7. That's actually pretty cool. I think I'll have a profiler telling me how long and slow these scripts are and giving me some warnings, but nothing's moving too slow. That one's starting to run at half a millisecond. So let's just go in here and see what we can do. I'm going to right-click on here and edit and bring this number down to a smaller number, maybe 45. And you'll see that has an influence on that. And another way to do that is hit your middle scroll key and lock your solver while you slide these around, and then unlock the solver. And you'll see you have less of a chance of bugging out your computer. So we basically have a series of circles, a range of circles that run from the center to the end as a radii. And it tells me what I have. And of course, I have one invalid circle because a 0 radius on a circle is very hard to calculate a circle. And the wonderful note here is clean tree. I use it often. And these are Booleans that default to true. So it is removing nulls from your data. It defaults to true here, which removes invalids. But it doesn't remove empty sections. And here you'd have to set that to true. But I just did it to see what happens in here, that it's removing the null. The invalid circle counts as that. Or invalid, sorry, I'm removing the invalid. Maybe I'll just type here and hit a 1. And that now becomes an integer value of delete or not delete. So if I think about that, if I move that down to the false, you'll see I get back my invalid circle, even though I'm cleaning the tree. So you could use the default, and that's just something to really give you use of cleaning tree. I use it often. I kind of feel like I'm not managing my data well if I have to use it. Like, why didn't I eliminate back here that domain had to be greater than 0, and then I wouldn't have to use my clean tree. So when you get into the habit of using clean tree, maybe you could just tighten up what you're doing before it. The next kind of nodes that I really enjoy and I learned through a robotics lab was the Entwine, which maintains a data structure as opposed to a merge. So Entwine is a great organizational node. Notice the subtle difference between the merge node and the major difference with the weave node. So if we jump in here and say, let's take this geometry that we ended up making, let's graph that data so they're all in their own branches, and rotate that through a 2π, you'll see I can actually take it and rotate that wonderful object around in a 3D form in many ways. And I've done that in the X, Y, Z direction by hitting Shift and pulling in my axis on the X direction, Y direction, and Z direction. I think it's a very beautiful script to actually drive geometry and maybe oscillate through and make some 4D animations. And of course, 0 to 2π is how I like to think as opposed to degrees. If you're a 0 to 360 person, go right ahead. But I just think you owe it yourself to start wrapping your head around pi and what that might mean. I might leave this at a 0 or a pi, or what's nice about pi is you can right click and edit snapping and say, okay, I'm going to be keeping this at 0 on the one end of the scale and 0.5, 1, and 1.5, and then it'll snap to those numbers and also snap to the end. So I can start to say, okay, there's our set 0.5. Just curious if I actually did that. I'll go back into here, edit snapping. I did, but I put 2 points in here, so it's not reading it. Let's click that. Now it should snap to 5. 0.5 should snap to 1. should snap to 1.5, and this should snap back to 2. So you can kind of play with those 1/4 and 3/4 divisions of pi. Okay, so I have my circles, they're moving, and I decide with the data I had before to merge that data all into one list. But I thought it'd be better to take this data and entwine it to show it maintains a nice system of data structure, and then put those circles back into 2 separate sections as well, and then throw it through a very interesting multi-pipe tool. Because my radii are a little small, they're probably not touching, so I'm not really getting the effects of that. But there where the radii is a little bigger, or the node size, let's see if it just chose the other ones. They actually do cross over, and I get a very nice tight subdivision, which is a new type of node geometry that merges the meshes with the NURBS curves in Rhino. And I really think if you can manage your data, produce beautiful point fields, structures, use line work, you can always solve your final geometry if you need a quick fix by the end of your project with these subdivision nodes. So that's just a tip from me. The weave pattern is beautiful because you can start weaving the patterns as true false in these directions. Like which ones do you want to grab, which ones do you then want to grab, and I have to wonder if I take these weave circles and put them in here, what kind of geometry I end up with and what I could start editing out. So you will get some wonderful forms. You can of course delete some of these vectors to have less into more, but just a very interesting, oh, I've got a weird snap here. There we go. Of course I have my snapping on and I want to look at it in between those snaps. But wonderful, powerful nodes. If you can start to wrap your head around here, and then I consider what the function of these 2 nodes do, I'm going to suggest taking a look into prune tree and into trim tree. And because the path mapper actually trims the tree to a certain level of depth, and the prune tree has a maximum minimum, I'm going to leave that open for people to request more information on and play with a little bit. But I think that's enough for this first video on data trees, certainly sets within the tree section. There's a lot going on there. I'm going to take that to disable. What I will continue with is 2 more sections at least on taking a look at tree statistics and the use of that through shift paths. We'll start to use masks, and then as we move through we might actually get into some offsets on the relative items. So the next section I'm going to focus in on masks, and the next one will deal with offsets. There's few and far between videos on this online, but there are giants that really have taught it well, and certainly taught me a lot, from Mode Labs to Daniel Kristev to BIM. I'm trying to think of any corner, which is really nice. It deals with kind of. Anyway, their icon's wonderful. I think he has great tips in Grasshopper, and they just continue, and I'm really impressed with them. So I've tried to highlight the ones that have really done some core teaching for me, and then bring it out. Let's just grab the geometries here and see what pops up visually, and it might explode. There we go. So we're starting to analyze information and moving and stepping and staggering things, and we'll try and bring the number count down so we can make sense of this very complex geometry. Thanks for watching. We'll do the second and third part of set trees in a moment.